Hi, this is Dr. Roshni Yehuda. I am a practicing architect specializing in energy and environmental design of buildings, and have been working as an academician, researcher, and practitioner in this field for more than 20 years. Along with my team at RUA and RUA Ecospaces, we endeavor to provide you with holistic and progressive solutions to the challenges of sustainability. Today, we will provide you with a brief introduction and overview of ESG and green buildings. Globally, as well as in India, the impacts of climate change have been steadily increasing. Incidents of unseasonal floods, forest fires, increasing hurricanes and cyclones, droughts, and high summer temperatures have been observed all over the world. There are also the less visible effects, such as land submergence from sea level rise, receding glaciers affecting food security, ocean acidification, and resultant loss of ocean biodiversity, all of which are a direct result of anthropogenic or human induced carbon emissions that have increased by nearly 50% since the Industrial Revolution in the 18th century. India ranks third in the world after China and the United States in its contribution to global greenhouse gas emissions, and also ranks among the top 20 nations at greatest risk of climate change impacts. At the COP21 in Paris in 2015, India signed the Paris Agreement, a legally binding treaty now supported by a total of 195 nations. India's updated pledge under the terms of the Paris Agreement include to reduce the emissions intensity of its GDP to 45% below 2005 levels by 2030, to produce 50% of its installed electricity generating capacity from non-fossil fuel sources by 2030. At the COP26 in Glasgow, India committed to achieve net zero targets by 2070. In line with these commitments and in keeping with the global trend on disclosure requirements on environment, social, and governance, or ESG responsibilities, the Securities and Exchange Board of India, SEBI, mandated a Business Responsibility and Sustainability Report, or BRSR, for the top 1,000 listed companies by market capitalization starting financial year 2021-22. The aim is to establish links between the financial performance of the company and its environmental, social, and governance performance, thus providing stakeholders a fair estimate of the company's overall business stability, growth, and sustainability. Briefly, the ESG parameters spread across 9 principles of the NGRBC, or National Guidelines on Responsible Business Conduct 2018, are based on the United Nations 17 Sustainable Development Goals. They include environmental parameters such as minimizing carbon footprint, developing climate resilience, using environment-friendly materials for construction, reducing resource consumption, and protecting natural resources and biodiversity. Social parameters such as improving diversity, equity, and inclusion, understanding the social impact of the company's products, and ensuring health, wellness, and safety of labor and employees. Governance parameters include inculcating responsible corporate behavior, enhancing transparency in reporting, and increasing community-based engagements. Building construction and allied activities has the largest impact on the Earth's ecosystems, second only to agriculture. As per the World Green Building Council, they are responsible for nearly 39% of all carbon emissions in the world. Additionally, as per the United Nations Environment Programme, building construction accounts for 1/3 of global energy end use, 40 to 50% of the total flow of materials in the global economy, 12% of global water use, and 25 to 40% of solid waste. Green building is a holistic approach to sustainability encompassing energy efficiency, water conservation, waste management, providing better indoor environment quality, enhancing vegetation and biodiversity, and reducing the overall carbon footprint. The three cornerstone principles of green buildings are resource optimization, that is, to achieve self-sufficiency or net zero in energy, water, and waste. Improved environment quality, that is, to improve the indoor and outdoor environment quality of occupants. And circular economy, that is, applying the principles of reduce, reuse, and recycle. Many voluntary rating systems are available today to certify green buildings. These provide third-party endorsement of green buildings by evaluating it against a set of criteria that are based on established benchmarks and standards, such as the National Building Code, NBC, and the Energy Conservation Building Code, ECBC. A building meeting the bare minimum requirements will be certified green. Higher levels of performance can be achieved by reaching silver, gold, or platinum benchmarks, or 3, 4, and 5-star levels of rating. Green building certifications include IGBC rating administered by the CII's Indian Green Building Council, GRIHA or Green Rating for Integrated Habitat Assessment administered by TERI, GEM rating or Green and Eco-Friendly Movement administered by ASSOCHAM, and Leadership in Energy and Environmental Design or LEED, an international certification administered by the Green Building Council. In addition, there are others such as WELL and EDGE standards accepted internationally. These green building certifications help certify various types of buildings that include new and existing structures, commercial buildings like offices, shopping centers, IT parks, residential buildings, both single and multi-dwelling, factories, warehouses, schools, hotels and resorts, hospitals, as well as interiors. Let us look at the major parameters under green building certification. Site selection and planning. This includes measures to conserve the nutrient-rich topsoil by stacking, storing, and reusing it post-construction. Practice soil erosion protection measures such as creation of sedimentation tanks and swales during construction. Follow pollution abatement principles and construction management best practices during construction, including wheel washing of supply trucks, barricading site to reduce air pollution, and proper storage and segregation of materials during construction. Protection and transplantation of existing trees and vegetation on site, and reducing the urban heat island effect by use of grass favor blocks, shaded pathways, and parking areas, and use of vegetation or high SRI tiles on the roofs. Water conservation. This includes providing water-efficient equipment in the washrooms, such as low-flow faucets and shower heads, dual flush cisterns and waterless urinals, harvesting and storing or recharging the rainwater, and reusing it for non-domestic uses, recycling and reusing wastewater to meet landscaping and flushing requirements, automated and water-conserving irrigation systems such as drips and sprinklers, and providing water meters to measure and optimize water usage in the building. Energy efficiency. This includes creating an energy-efficient envelope by using building materials which have a high thermal performance, thus reducing the heat gain and leading to lower operating energy requirements for space cooling. Use of energy-efficient lighting and equipment, use of renewable energy such as solar, wind, and biomass, and energy sub-metering to track performance using a BMS or building management system. Since building air conditioning consumes a large percentage of operational energy of the building, Installing energy-efficient HVAC such as VRF systems with low ODP refrigerants is required. Compliance can be achieved through prescriptive or energy simulation software depending on the specific case. Building materials and resources. This includes efficient waste handling during construction, provision for segregation and treatment or recycling of waste post-occupancy, use of materials with recycled content, reuse of salvaged material, rapidly renewable material, and use of materials that are sourced locally to minimize the carbon emissions from transportation. It also implies using materials with low embodied energy like bamboo, stabilized earth or cavity blocks, and materials that utilize industrial or agricultural waste such as rice straw or husk, fly ash, and GGBS. Indoor environment quality. This includes provision of adequate fresh air as per norms, air quality monitoring during construction, indoor air quality testing and carbon dioxide monitoring post-construction, use of paints and finishes with low or no VOC, that is volatile organic compounds, some of which are harmful for health and known to cause chronic diseases. So, green buildings not only reduce the impact on environment, they reduce your electricity bills and your energy consumption, and thereby your carbon footprint, while providing you with better thermal and visual comfort and better indoor and outdoor environment. They conserve water and utilize 50% less water than a conventional building, and they reduce and minimize waste and pollution. The cost of a green building may be 8 to 10% higher than a conventional building. The additional capital cost being investment on infrastructure such as wastewater treatment, rainwater harvesting, and renewable energy. However, once the payback period is over, these efforts yield long-term benefits, enabling the building to become self-reliant in resources. I hope this presentation has provided you with a basic idea on ESG and green buildings. Do complete the appraisal to see how much you have learned. Thank you.